Where are we? We're at 3 o'clock. 3 o'clock. Hey. Nice. All right, let's see. Oh, shush, puppy. Shush, 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 shush. Oh, don't cry. Don't cry, little one. Don't you cry. Don't you cry. Look, it's Henry. Henry, the crypto cavalier. He hates my desk because it's slippery. It's like too polished. His paws just slide all over it, and he's completely immobilized. So I tried putting him on the desk while I navigated some stuff. He started whining. Again, this is not my puppy, but I get to babysit him every once in a while, and this is one of those whiles that I'm wanting. So, isn't that right, Henry? Isn't that right? Who's a good boy? Henry's a good boy. Henry's a good boy. He's bigger. It's been a week since you've seen him, and yet he's already bigger, huh? Look how much bigger you are. He's growing so fast. Aww. Oh, you wanna go back to Lamb Chop Doll? All right, come on. Come on now, buddy. Ooh, I got a plan. Oh, wait, no, I don't. What if I put you here? There we go. Okay, that works. Yeah, I feel bad penning him up, but he's a little rambunctious lately. Especially more than last time. He's getting into that stage where you could tell he's kind of getting some adulthood concepts. Like Mikkel was telling me, my friend who owns Henry, that he started recognizing when she's not there and crying like a kid would at approximately 2, 3. So, oh, freaking hell. My entire phone just blowed up. It blowed up. Better put that on silent. Boop, boop, boop. Okay, folks. Welcome to the show. How's it going? I'm going to shut these blinds simply because it controls the lighting better. Look at my booty while I'm doing it. Aw, yeah. Big pimpin'. Big pimpin'. What? Big pimpin', yeah. I like it when you call me Big Papa. Anyway, guys, so... Okay. Welcome to the Shizzo. For Rizzo. My Frizzos. I like it when you call me Big Pidbos. My name from now on is no longer Colin Couché, it's Colin Lyon. That's actually worse. No, let me think about this. Colin Couchizzle? No, that doesn't work either. Let me think. Colin Douche. You could just call me Colin Douche. I've been called that so many frickin' times, I'm used to it. Alright, so. Today's Free For All Thursday. It's one of my favorite days because it's free for all of you. Do me a favor. Like, share, promote, tell everybody that the show is on and that it's wonderful and that it's beneficial to everybody's health that they joined this program today. Because it's a lie, but it makes me feel good. And, you know, maybe retweet this or something. I don't know. All right. Got to build that audience. Got to beg for people to like you. That's basically what Twitch streaming is. It's begging for people to like you in real time. I mean, I guess you kind of do that on Twitter too. You do that on Twitter, you do that on Instagram. It's like me, like me, like me. Please, I need your love. Mommy. But, you know, you're just constantly liking, you're just constantly asking for people to like you. Like, hey, like, tweet, subscribe, like, tweet, subscribe. And, you know, it's not a good feeling to ask. You might see my eyes roll a little bit. It's because it's not a good feeling to ask for you to like me. It's really not. It's a little, slightly on the pathetic side. Hold on one sec. I'm a stickler for lighting. I was getting that, well, I'm not really that much of a stickler. I just like to control it. I had like this backlight that was bothering me. So, yeah, I mean, like, subscribe, follow, hit that follow button. It hurts nobody. Hurts nobody. Hit the follow button. You don't have to pay a damn thing. Promote. Tell people. Tell the world. Tell everybody about the benefits of taking your 3-day-a-week dose of Colin Douche. Fell Now, thank you very much for your subscription. I appreciate it. Fell Now with the Prime. Appreciate you. That is your monthly freebie, and you gave it to me. I appreciate that. I'm not in this for the money. I'm in this for the glory and the fame. Honestly, I'm in this because there's an education gap for Avalanche. It really is. There's a huge education gap. There's a lot of people who know about it, but don't know what differentiates it, why it's going to be a top 3 coin, token, whatever. A lot of people just don't understand what's going on here or why it's so monumentally important. You know, they've been listening to people like Charles Hoskinson and Dominic Williams and Gavin Wood for so long, you know, Dan Larimer. And these people made the Ethereum group. These people have made promises for so long, and none of them have delivered. And then out of like nowhere, in like 15 months, we deliver something. And it's a hard story to tell in that background. Like, signal versus noise is a problem. How do you make your signal? How do you make signal in an industry full of nothing but noise? So I started a stream. I don't know if it's helping, but it will help if you guys start promoting. I promise I will dunk on every one of your projects. It's true. I am discerning as hell. I'm probably the wrong person for this job. I'm probably the wrong person for this job. I'm probably the wrong person to be doing this. Simply because I'm a little too honest. And sometimes that means I gotta, like, trash on myself too. And that's what I'm doing right now. I might be the wrong person for this job. But I'm the only person who will step up and do it. And who's got the background, who can actually explain some of this stuff. But again, I might be the wrong person to be doing this. And that's okay with me if you know, it becomes a problem. But right now, I'm just going to go with what I know. I'm going to go with my gut. I'm going to focus on legitimacy. And for that, sometimes I might have to dunk on a project in the ecosystem. I won't dunk too hard. I'll try and give constructive feedback, of course. But that's where we are. We're in a space where there's too much noise and not enough signal. And I'm trying to produce signal. So, welcome to the stream. Free for all Thursday. We can talk about anything we want. Right now, I wanted to talk about my vision for this stream. Vox King, I can't promise that. If what you're building is stupid, I will tell you it is stupid. It's a risk you take. You know, it's a test of your own confidence in your project, right? I'm not gonna go like hard on you. I'm not gonna be like, oh, this is like, I'm not gonna like look at your project and just be like, uh-oh, retard alert. I will probably say that this won't work if I don't think it'll work. And that is something you'll need to work on. And I might even give some advice on how to make it better. Or I could be completely wrong. You could tell me to go kick rocks and then you make millions and millions of dollars. Like the guys at Matic and Polygon did. Because I told them that their stuff was junk. Utter, absolute junk. Read that white paper, if you could call it that. Talked with the founder and was like, this is junk. And look how much money they made off of that junk. Value is absolutely impossible to determine in this space. Yeah, all I can do is pump the real stuff. And the thing is, the real stuff eventually floats to the top 100% of the time. Always. Yeah, well, Mark Cuban's got a real good batting average just picking winners on this, huh? What was it, Titan? What was it called? Anyway. All right. Starting from the top down. Let me acknowledge the people who've been talking in chat, who I have slightly ignored a little bit. All right, so Almarino99, thank you for coming back. I appreciate you. He said it was pretty interesting seeing you yesterday going over code on GitHub, giving us an idea of what the thought process looks like for someone in the business. You're welcome. It is exhausting for me to do that. I never liked that in my life. It's one of the reasons why I've been working in crypto, trying to find a different way to spend my time that doesn't drain the hell out of me. But I'm happy to show you how I did it so people who don't get drained can maybe do it too. It's not a bad field to get into, but after 20 years, you got to start looking. You got to, like, if you're doing 20 years of anything, you're going to get to the end of that 20 years and go, what else can I do? I gotta do something other than this thing I've been doing for 20 years, you know? And that's where I am. So maybe there was a time when I had love for the game, the coding game. Today is just not that day. So I'm happy to go through my process, what I've learned over the years, and what I can do to help people get off the ground. Also, people how to find things in the Avalanche stuff that we built. You know, that's why I'm here. That's 100% why I'm here. You know, I want people to just be like, every time they're on the show, like they're just like, I can't believe I figured something out, and then they'll build something and everything's just gonna work for them, and they're gonna make millions of dollars, and they'll be happy, and everybody's just gonna be like, you know, you're the best, and they'll be all like, and then the markets will. And then they'll go bankrupt. God. How am I single? All right. So, let's see. So happy to go through that stuff. I love it. I love helping people. I love when I get intelligent questions that I can help answer. I love when I get less than intelligent questions so I can make somebody ask what. The cool thing I've noticed is that sometimes, like a lot, almost all the time, when somebody asks like the less than intelligent questions, I notice that if they keep asking, eventually their questions get to the point where it's just like, oh, wow, you caught up. And now you are asking questions that are way above my head. I love that. When people have passion, they figure it out. And they're not afraid to ask questions that are a little out of their quote unquote, I don't know, pay grade, maybe the word for it, like a little over their current level. Like that's fantastic. Like that's a sign of a person who's not afraid to learn. And I'm happy to work with those people. What I'm not happy to work with is people who are unaware of what they don't know. And sometimes that's me. I'll be honest with you. That's everybody at some point. I try to avoid it. Try to play dumb as much as I can just to avoid that. But I hope you guys correct the hell out of me when I do things wrong. Like, I think I said that Cardano was classical because it had a coin flipping algorithm. Apparently that's wrong. I'm not really sure what they're using to do that coin flip, if it's not, or if they still even have it. But I thought that was like a classical choke point for them. I was wrong. Apparently that's not an issue. Apparently they are pure Nakamoto at scale, which Ouroboros is, I should say, not Cardano, which is interesting, but I'm not sure about it yet. Like, I need to look over it more. Maybe that's something we can do today. I don't want to shill Cardano. That's the problem I'm dealing with here, because like I don't know if it works, and like very few people have been able to use it or build on it, and it's so complicated. Like, I feel like if something works, you should be able to explain it easily. Avalanche works, and I can explain that easily. It was not difficult to explain it. Mother of God, what the principal concept that made it work was, you know? But like, Avalanche is easy to explain, in my opinion. It's always been easy to explain, and part of that's just because Goon's good at explaining this stuff. But like, nobody has been able to explain Ouroboros to me in a way that was clear-headed, and that makes me think it might not be clear-headed, because every time I look at it, the paper's 67 pages. It's 67 pages of junk reading. Like, they use their own notation. Sometimes they misuse words. From last I saw, it was just like, what are you doing here? So when I read this, like the white paper on the Cardano site and stuff, and so it's like, and it was just like, what is this? Like, the Avalanche white paper, I think is like what? Like, so the Bitcoin white paper is like 9 pages maybe, and like the Avalanche paper is like 21, but that's only, I think, if you count the appendices and the references, which, by the way, huge list of references. So let's take a look at like the Bitcoin original white paper. I want to show you something. Whoop. Boom, 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 boom. All right, so this is look how clear this is, though. You could tell somebody had a very clear idea before they wrote the paper. Before the paper was written, the idea was clear in their head. They weren't like shaking around trying to make something happen, right? This is a clear vision. It's very succinct. A whole section is less than a page, okay? And it builds right up to the points of like, how do I even just like prove that the probability of the whole thing is like, now again, I'm sure a lot is left out of here, but like, this is a clear vision. It's 9 pages long, and that's counting the abstract and introduction, which we all know is fluff every time. It's helpful fluff though, you know. And you get all the way down, and it's like privacy calculations. You go down here. Conclusion. The last page is the references. So you can chop 2 pages out of this. It is a 6-page document to explain Bitcoin. So there's a lot here that might be missing, but the overall concept of it is still like there. And like the explanation of why this probably works is all here. Like, there might be details that are missing, but that's okay. Like, you get the idea. The general essence of what you're trying to do is captured in this like, let's just say 7-page document, okay? All right. Did I just minus wrong in like a sentence before? Because like, yeah, whatever. All right, so let's look at the Avalanche white paper. All right, the Avalanche white paper, consensus. We'll focus on the consensus. See, here's the other thing. Is like they keep munging platform and tokenomics, and I don't even know why there's a stablecoin paper. Like other people like munge like the platform vision and the token vision into one paper sometimes. And you're just like, this is too much. Like I think IOTA does a lot of that stuff. Consensus is a particular concept. Oh my God, did I do that again? Oh, guys, I'm so sorry. I'm so sorry. I've been sharing my screen this whole time. I've been failing to share my screen this whole time. Here you go. Bitcoin white paper. All right, let's just reiterate what I said before. Look, you got an abstract and an introduction. It's 1 page, okay? Can you see it? You should see it. Okay, you guys see it. Fantastic. I am sorry. All right, so the white paper is like what the first page is like basically build up. Like, here's what we're trying to do. Let me explain the concept of this, right? And you go down, and then it starts getting into like what is like basically the basics of like, this looks like transaction format, okay? And then this gets into how blocks are formed. And this is like literally a tiny section. Yes, this is leaving details out, but it's showing the overall essence of the idea very clearly. Like you can understand this and go, I get this. All right, so this is fine. Okay, yada, yada, yada. You get all the way here. It's like your page 8 or something. Very clear. There's a little bit of proof in there about the probabilities of yada, yada, yada. Okay. Conclusions there. Always necessary to have that. And then you got your references. The last page is half a page of references, right? It's straightforward. It's straightforward. People can look at this and go, I see what you're trying to do there. I think that might work, right? I think that makes sense. Okay. Avalanche. Much more academic, but still 21 pages. And I want to point out that of those 21 pages, introduction is, let's just call it 1 page, okay? There's math and figures in here that prove everything you're saying. There's pure algorithms. Literally straight up pseudocode. You can read and understand this, okay? It might be on the academic scale of things. In other words, this is using very academic language, academic formats, really more up there in the academic-y space. You can see this, though. You can see how they're doing this in a very, like, they produce this in LaTeX. Let me put it that way. Like, they didn't do this in, like, you know, Word. All right, so liveness. It talks about concepts like liveness and blah, like it's literally building up. And it's, by the way, this is like 3 papers in one, I want to say, because it really is actually 3 papers in one, from my opinion, because there's 3 papers here: Snowflake, Snowball, and Avalanche. Okay. So you literally have, well, Slush, I guess, too. So it's introducing the concepts in iterations. There's like 3 big concepts it's kind of doing. And to be safe, it's kind of like mushing them all together, right? And that's a really interesting way to do things. It could have been split out into multiple papers, which are proven over a longer period of time, and then it would have been introduced, but instead it was all introduced in 1 paper. Okay, fair enough. I see why that happened. You need to get it out the door. You need to get the idea out the door. If they already know the answer, just do it. But I guess this could have been split into several papers where they proved it iteratively, right? So you got Avalanche, and Avalanche is just adding the DAG, blah, blah, blah. This is actually where the actual, like, consensus protocol final form kind of, like, builds up. Snowflake is the primitive it builds up. Then you got the Avalanche, actual Avalanche. This is what you build. This is closer to this. Okay, this part is closer to all of this, all right? And even then, it's leaving out transaction format because it's just not relevant. We can build transactions in any way we want. All right. Talks about UTXOs, and so this is getting a little more into, like, this is how a consensus protocol would be built using the Snowflake primitive. That's what Avalanche is, by the way. Snowflake is primitive. Snowball, I was saying, is a primitive. My bad. And Avalanche is the protocol that can be built with that primitive. So technically, Snowball, Snow Consensus is the actual consensus. Avalanche is just sort of like the first way we've shown to use that. And like Snowman is another example of a consensus protocol that uses the Snow Consensus, but isn't Avalanche. So, anyway, so yeah, it's basically just proposing a protocol at that point. Now we've got some more proofs and stuff. It's really completely proven in here what the data is and what it means and how you can approach it and how you're supposed to analyze it. It's all clearly written in the paper, right? It shows an area for related work, right? Then you go to references and look how long the references are. Look how many pages. All right, so we got, let's just say 1/2 here, conclusion, whatever references. So let's say 1/2 for the references. Then you got 1, 2, 3. So let's just say 3 pages because the half before. And then we got this analysis and, appendix and blah, blah, blah. All these are at the end. So we've got maybe in actuality, we have a paper that is essentially starting from here, I would say, and a lot of this is also kind of fluff, like georeplication, yada, yada, yada. Like it's additional evidence stuff. Like, but from the actual, like, explaining of things to analogize it to Bitcoin, you're looking at 15 pages, maybe? 15 pages, right? With proofs included. This is real. Like, you can prove this. This is real. This is what good looks like, guys. Guys, this is what good looks like. Okay? This is what good looks like. This is what good enough looks like. This is what good enough looks like. This is what good looks like. And now we're going to go to, we're going to go to, let's just Cardano. Because I believe that that's where it is. Here we go. And I want to make sure I'm looking at okay, so there's a lot of papers here. I'm going to go to the one that Cardano's referenced. I just found it recently and now I can't find it because I forgot already. That's how I am. Should have been a research, right? Or maybe people, purpose, technology. All right. Cardano white papers. Where is it? All right, let me go back to look at the Ouroboros white paper. Okay. No, yeah, I thought like they had a list of white papers that they were using in their protocol. So I'm just going to go back to search for Ouroboros white paper over IOHK. All right. Is this it? Yeah. Okay, here we go. Guys, first off, let's point out something here. This is 6. All right, Acid Does Burn has called me out. Says I need to do a posture check, my brother. Thank you very much. JA, thank you very much. All right. By the way, follow my friend Crypto Does Burn. He has a Acid Does Burn. He has a good, let me pull it up here. Crypto Acid Burn? Is that it? Is this it? Looks right. It's hard to remember. Like, there might just be a different Crypto Acid Burn. Is that your right one, man? He likes everything I like, so I can just pull up one of my tweets and just check. Well, I think this is right. Is this you, man? Oh, that's not you. God dang it. I can never remember monikers. The problem is I know him in real life, so I gotta be like, he wants to go by the moniker, which is fine, but it makes it difficult because I can't remember URLs. I mean, like, usernames. Like, I'm terrible with it. Terrible with it. Just like one of my tweets, bro. All right, whatever. Crypto Acid Burn? Freaking hell. All right, well, you'll tell me later. All right. Just link it in chat. Crypto _Acid Burn. Oh. Let me give a shout out to my buddy. This is it. Man, you got like 36 followers. That's a shame. Shameful. Well, they banned his other account because he was actually, what he did was in his previous account is he'd find crypto scams and retweet them. So people who were scamming people, he would just put the like warnings and alerts up. The problem is he got flagged as a crypto scammer himself, and as a result, his account got taken down. So he had to create a new one. So yeah, just follow my buddy Crypto Acid Burn. He does try and help the ecosystem as much as he can. All right. Sad's chef reminded me that I needed to hydrate. What Sad's chef doesn't know is I just hydrated with coffee, which I don't think actually has the effect of hydrating. All right. Well, actually, might know. I don't know. So, let's look at the Ouroboros white paper here. Now, I'm not saying it doesn't work because I don't know anymore. I knew it didn't, but I looked at it in 2018, and like you look at this stuff once, you don't want to look at it again. And they keep revising it and coming up with new crap to make it work. You know what I mean? Like, oh, you mean the thing we published doesn't work? Well, let's just fix that and see if it works now. Like, it's not coming from a place of first principles when you start doing that crap, right? And so I'm very uncertain about the validity of this. That doesn't mean that I'm correct. Doesn't mean that I'm incorrect. Every part of my instincts, every fiber of my being says this has got a flaw in it somewhere. I doubt I'll find it. I really doubt I'll be the one to find that. It's gonna put me to sleep to try and read this on stream, but I'll try. It'll put you to sleep too. That's the thing you gotta realize. Like, it's not fun. It might be fun for a handful of you in here. It's pretty not fun. All right, so I want to point out that this is a 67-page document. Okay, the first. The first 5 pages, 4.5 pages are introduction. First 4.5 pages are introduction. Okay, cool. Skip down to the end. And starting at page 63, the last 5 pages are references and 1 appendice item. Okay. So and the appendice item is something about fork trust rolls and shit like that. All right, so I am not an expert in everything that they're probably going to be going over here, but I'll do my damnedest. Yeah, there we go. Sorry, yeah, I'm not really good at remembering the audience's needs. Thank you for pointing that out. So yeah, this is a big old document. This is a 67-page document. Again, for comparison. Bitcoin, 9 pages, technically 7. Avalanche white paper, 21, technically maybe 15. Okay? This is removing the same stuff. This is 67 pages, technically 59. Right? 58, something like that. Okay. So this is what we're going over. Abstract. Let me just start with that. Abstract, we present the Ouroboros, the first blockchain protocol based on proof of stake with rigorous security guarantees. We establish security properties for the protocol comparable to those achieved by Bitcoin blockchain protocol. As the protocol provides proof of stake blockchain discipline, it offers qualitative efficiency advantages over blockchain based off proof of physical resources, e.g. proof of work. We also presented a novel reward mechanism. In incentivizing proof of stake protocols, we prove that this mechanism and honest behavior is an approximation of Nash equilibrium. This is thus neutralizes attacks such as selfish mining. I gotta say, this feels like buzzword dropping. We also present initial evidence of the practicality of our protocol in real world setting by providing experimental results on transaction confirmation processing. Okay, so this is a pretty solid abstract for the first paragraph, but like I want to point out that like if you read the abstract from the Avalanche white paper, it actually gives some hard results, right? It's not just like, yeah, wishy-washy, blah, blah, blah. I definitely kind of like prefer abstracts that kind of say, hey, this is the results these are results we're getting, okay? And by the way, I want to go on record. These results in the white paper are lower than the results that we are getting in a network, right? So, like these are, we actually improved on these paper results. We actually got up to 18,000 transactions per second with a really light system that didn't have a heavy VM with signature verification turned off. Like, you don't care about that. If you want crash fault tolerant instead of Byzantine fault tolerant, you get a lot better results with Avalanche. Anyway, well, you still need signatures, I guess. Well, whatever. Just not as many. Anyway, so that's the abstract. So just stare off the bat. This is a little fluffy of an abstract. Could be better. But I'm not going to give that same like this is also kind of in the same category of this. So it's not like a blocker. Like, this isn't something I'm reading going, okay, this is crap, right? Because like it's about the same as the Bitcoin abstract. Like the Bitcoin abstract and the Cardano or Ouroboros abstract are kind of like, they're kind of, you know, both a little fluffy. Like for instance, like they got a proposed solution for the double spending problem using a peer-to-peer network. Like I would immediately go to that and go, is double spending really a problem? I don't really know if it actually is. That's another topic. I talked about that last time. Double spend is not the issue. You can always just ignore double spend transactions, you know. But they proposed a Leibniz first protocol, which means that they need to come up with a fork rule for those people who don't care about double spend, like who really want the double spend to happen. Anyway, so going back to Ouroboros, provably secure, blah 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 blah. All right, primary consideration. First off, there's not. Let me look at something here. Cool. Here's what I wanted to get. I was gonna look them up, and then I was like, wait, no, they put it down in the bottom. Interesting approach. It might be just a different way of doing things that maybe even other countries do. I don't know. University of Edinburgh. I mean, these are. It's a pain in the butt to like reference that. But like, all right. So first thing first, let's just check the credentials of these guys. All right, man, that looks like a freaking mugshot. Hate to be that guy, but that does look like a mugshot. Anyway, that's rude, I know, but like it does. It kind of looks like a mugshot. All right. Received a PhD in 2002 for City Nerve Advisors. Blah blah blah. Chair of Cybersecurity, blah, 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 blockchain innovation. All right. Worked on electronic voting, valid tangential field, I think. Combinatorics fitted, blah, 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 Bitcoin backbone protocol. So his work started like 2015 in Consensus. Key generations, yeah, okay, whatever. Yeah, so he has a background in mostly electronic voting. It looks like. So let's take a look at some of this. Now, I don't know what people do internationally, but my understanding is that in the United States, the way it works is you got the first author and the last author. So if you look at let's look at the Hot Stuff white paper. Okay, so let's look at the Hot Stuff paper and the was it last author or the first author? I thought it was last author, but maybe not. Yeah, okay, maybe it's the second author. Okay, so Dahlia Malki came up with an idea for Hot Stuff. Ted Yin implemented it, and so he was a student on for implementing it. He was the lead of the project at the university, so he's first author of the paper under supervision of Dahlia Malki. That was my understanding of the situation. She was the one guy, like the one, basically putting the whole thing together, and then there's that. So anyway, here we have, he would be the implementer if this were the case, and that means that the second author would be Alexander Russell. And yep, UConn. Cool. That makes sense. He's got a bachelor's from Cornell. PhD from MIT. Very prestigious schools. Cool. So let's see what his background kind of is. Proof of Stake. Ouroboros Praus. Ouroboros Genesis. Quantum cryptography. Started with Ouroboros. Cryptography. Efficient encrypted password for multi-user. Blah blah blah. International. My understanding. So like I'm not deep into Hot Stuff, man. I jumped right into Avalanche. But my understanding is that it used signature aggregation to increase or decrease the message complexity of classical protocols. Literally, that's it. And so the story I'm told is that basically a bunch of guys, the ETH guys and the Cosmos guys were talking with Dahlia Malki and said we have this idea for how we can actually reduce the message complexity using cryptography, and they were like, using signature aggregation. I believe it's BLS, but really I think any signature aggregation scheme will work. And and they said, oh, okay, well, we'll look into it. And then the resultant was Hot Stuff. That's my understanding. But I did not dig into Hot Stuff. I'm not a consensus protocol expert. I've got a bachelor's degree in computer science. Everything I learned on the job. And that's pretty much been true my whole life. University didn't help much. All right, so that's all I know, and I haven't needed Hot Stuff. So I can't really tell you. I can tell you that the message complexity, I believe, is n log n on the average case. It's still O n squared on the worst case, I believe. But the worst case is astronomically unlikely. So that's my understanding. I might be wrong about that. I think that's the case, though. So that's pretty good for an average case in a consensus protocol. So it's an optimization over classical, which is basically Paxos. Of course, it might not be Paxos either. I have to double check what the derivative, the root, kind of like inspired consensus algorithm is. But anyway, the point is that use signature aggregation as an optimization to actually, I wonder if the hold on. I think I actually might know what that optimization is. I think it's leadership election. I might be wrong. Where did that paper go? I thought I opened it. Yep. Yeah, okay. Yeah. So it's leadership election. It's kind of like, I guess, a little bit like the way Dfinity kind of does it. I'm not sure, though. But if it's like that, then it's basically using BLS for signature groups to actually do a leader election, so that it's an optimization for that leader. And then if the leader drops off, then they have to do another election process, which, of course, is a little more time-consuming and stuff. But, yeah, no, I think it's better leader election, so it's got to fail over in case a leader becomes a problem. All right, I don't know. I'd have to go over that one too. Let's see. All right, so Ouroboros. Let's see. Alexander Russell seems qualified. So we got Alexander Russell as the qualified person to do this. He does seem like he has a background which could actually handle this. So that's good. That's a plus. See, I'm giving pluses here. Giving Ouroboros some A++. All right. Fundamentally, the proof of work mechanism, Bitcoin, blah, blah, blah. Okay, yeah, we know. Yeah, okay, maintain a block size, relies on the stakeholders themselves to sign this work, blah, blah, blah. Okay. Right, okay. Concept of POS has been discussed extensively. Bitcoin forum, bit proof. Okay, yeah. Why POS has been a challenge. So the fundamental problem behind proof of stake is that, yeah. Hold on. For instance, an adversary controlling a set of stakeholders may attempt to simulate the protocol execution trying to different sequences. So it finds a protocol continuation that favors the adversarial stakeholders. This leads to a so-called grinding vulnerability where adversarial parties may use computational resources to bias the leader election. That's assuming... So, I mean, my understanding of the proof of stake stuff is that proof of stake, in order for you to use proof of stake, you're basically trying to say that X stake has more value, which is of basically ability to propose blocks. So the problem with that is that if you have value as the way of deciding hashing power, then essentially there's no way to elect a leader unless you have a voting protocol. And unfortunately, all voting protocols fall in the classical realm until now. And so because all voting protocols fall in the classical realm until now, there was no way to actually produce a blockchain, a live first blockchain, by the way, that had more than like 100 nodes without seeing performance degradation. And so that's why proof of stake wouldn't work. I'm unsure what they're talking about with the grinding vulnerability. I'm sure it's something in the vein of that. I'm just trying to grok where they mean where that means. Because the leader election shouldn't matter. Like you should, like literally the stake should just take care of that. It's a Sybil protection mechanism, first of all. So it's meant to... All right, I'm ignoring my chat. Hold on one second. Let's see. About the dynamic fees on Avalanche, will it be a global default fee that is dynamic or will be set by the user? I think it's going to be governance. I think it might not be governance. No, it's not governance. It's variable adjustment, and maybe that adjustment variable could be governed. I don't know. I actually don't know. Since React do you think about Babel fees? Is it possible to implement such a thing? I don't know what Babel fees are. All right, so the fundamental problem, people, blah, 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 our results. We present Ouroboros a provably secure proof of stake system, the best of our knowledge that the first blockchain protocol. Okay, yeah, fine. Okay, fine. Again, what we're doing, blah, 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 blah. We just say block withholding, selfish mining, blah, 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 blah. All right, yeah. Know this. Yeah, so I don't think double spending are actually problems, but whatever. Nothing at stake is also not a problem. Desynchronization attacks. Don't know what that is, really. Evidence for practical efficiency of our design. First, we consider double spending attacks. For illustrative purposes, we performed a comparison of Nakamas. Okay, cool. Okay. In parallel to the development of our bars, another. Okay, got it. So if I hear sleepy consensus, we're talking about fixed stakeholder distribution. Snow White addresses evolving stakeholder distribution and uses corrupt delay mechanisms similar to ours for arguing security. I don't know why. Okay, Algorand provides a distributed ledger following a Byzantine agreement per block that can withstand adaptive corruptions. Why are they putting Algorand in? Oh, sorry. I'm in the related work area. Okay. I never heard of Snow White and Snow White and what's the other one? Sleepy. I never heard of this. All right. So lay out the base model. So in-house for our protocol, we present 4 stages outlined in section 3. In short, section 4, blah, blah, blah. Okay, goddamn. Yeah, I'm going to read this just because even though it's boring, I need to know. They lay out the basics in section 2. Simplify the analyzer programs. We say 4 stages outlined in section 3. In short, section 4, we describe and analyze the protocol in the static setting. We then transition to the dynamic setting in section 5. What the fuck are those settings? Did they mention that earlier? We then present the protocol enhancement within anonymous channels in section 7. Our incentive mechanism and the equilibrium argument are presented in section 8. Following this, we discussed delegation in section 9. Section 10, the resilience of the protocol under various particular attacks of it. Jesus fuck, I'm already tired. All right, model, time slots, and synchrony. Let's start with this. We consider a setting. Guys, are you not bored by this? Like, I'm already bored. It's a form of paying the transaction fees with the token. So homotopy type theorist said it is a form. Babel fees, I think he's talking about, is a form of paying the transaction fees with the token you are using. Using a different token to pay the fees is troublesome for using a different token to pay fees is troublesome for newbies, in my opinion. Oh. So you're saying if I have so Avox is the base token, right? So you have Avox as the actual base layer token that you're trying to send around. Okay, fine. I'm trying to send a box from person A to person B. That's fine because I just pay the fees in a box. But if there's a token called like Spore on the Avalanche network, and I'm trying to send Spore from person A to person B, then I want those to represent my fees in the value of Spore. Well, without some sort of market pricing oracle to do an exchange rate on that, that becomes a problem. So you need a built-in AMM into the system, basically. So it's got to like have a canonical AMM, which I'm not particularly comfortable with. I don't like that idea, but you know, whatever. You still, and even funnier than like that exchange in the AMM still requires some sort of transaction fee to sort of like, I guess you would just do all exchanges through an AMM protocol. So, I mean, yeah, I don't know. Because then in order to actually create a token, you would need to set up liquidity against that token. So if I was to create a Spore token, I would have to create a token pair in the AMM called Spore, and I would have to, for every Spore, I'd have to establish a fixed price, and then I would have to provide liquidity in a Vox just to make that happen, or some other token just to make that happen. So I'd literally have to create liquidity pairs for every token that I'm creating. So if I wanted to create a Spore token, I'd have to create a Vox token, a USDC token, a Vox Spore pair, a USDC Spore pair, a USDT Spore pair. I'd have to create like all these a Pangolin Spore pair. Like I'd have to create some way of actually making these pairs, you know, sort of like balance out in some way. So I actually think that's kind of harder for people to set up new things, and it makes makes it more difficult for people to understand what their fees are going to be. I don't know. I think just keeping it in a Vox makes more sense personally, but maybe I'm not thinking hard enough about that. All right. So it's also like, why are we always overcomplicating things? It's driving me crazy. I keep hearing people like, oh, we have a problem. Let me build this giant mechanism to solve it. It's like, well, why don't you just do this work in the UI and make it completely transparent to somebody somehow? Or have a service which provides this, or some DeFi contract which does this for you. And I feel like these are all things that are, well, even then you'd still need the Avox just to do the transaction. Yeah, I don't know, man. I honestly don't know. I don't know. Like, you still need the Avox just to do the transaction. So postage tokens make sense to me, but that's a Vox. It's still a Vox. You want me to read this? Dude, I am desperately trying not to read the Ouroboros paper, so like, I'm just gonna go back to reading that. Did y'all want me to read this today, like for real, or do you just want to like interrupt me while I'm reading it and then like literally like look at everything that you send me because I'm already bored. I'm happy to like not do this. Read the postage, fine. Because like I'm here to answer questions and stuff too. I'm not just here to like gratify a few people who want me to read the Ouroboros paper, which by the way, I don't know if I can do that on stream. It's just 60 pages. Like it's huge. This is so much to go through. And look at all this, all these symbols, and like it almost feels like it's intentionally made hard to understand. This is what I'm trying to get at here. I made this narrative, all right? The narrative was Bitcoin was easy enough to understand that people could read it, get the basic idea of the whole fundamental principle behind it, and believe that there was a kernel of truth to that and implement on it, right? And then you get to like Avalanche. And again, and by the way, Ethereum's white paper is the same way because they're just talking about the virtual machine because they're just literally going, we're just going to stick Nakamoto consensus on a virtual machine. There was nothing like in account models too. Like that's straightforward stuff. Everybody knows what a Merkle tree is. We knew that way before Ethereum. Like that's not news. It's like Patricia Merkle trees. Okay, whatever, you know, it's a Merkle tree. So, but like, look at this. This is also very easy to understand. Like you can digest this. There's not like already like using ridiculous symbols and things that are non-standard. Like everybody knows that epsilon means the tiniest little delta of a thing. Tiniest little error, or like tiniest little change of a thing, I guess. Tiniest little bit. Or actually any bit. It's not even tiny, it's just arbitrary. So like everybody knows that from freaking like calculus class. Like that's not a big deal. Like if you're sufficiently advanced enough to understand this, you should be fine. It's talking about the liveness and safety, and like these are basic things that it's addressing, and it actually provides pseudocode to help you navigate the understanding of this paper, right? And this is a really easy to understand paper compared to this mother effer, which is just already, I'm on page 6, and just jumping into the part where it's already starting to drop like heavy loads of like, what is this? So for every K in the natural numbers, I assume that's the natural numbers, once a node on the system proclaims a certain transaction is stable, the remaining nodes have a query to report the transaction, blah, blah, blah. With every U, and it's like, and like, I get it, like, you could just say that, though. Like, could just, like, it's not necessary to church it up. Anyway. It just reeks of like fake marketing. That's what I'm saying. It reeks of just junk fake marketing. And for the fact that they haven't been able to deliver, I would not be surprised if that was the case. Yeah, but I can't go through this on the stream, guys. Like, there's no way. You guys are going to fall asleep. I'm going to fall asleep. I'm going to lose viewers with how freaking boring this paper is. I don't know. That's the problem. What is the gist of Ouroboros? What is the core idea behind Ouroboros? Literally, what is Ouroboros? What does it even mean? What is it? Like, what is this? What is it? Just tell me. Like, I can explain to you Avalanche in 3 paragraphs. I've written stuff on it. It's not hard. I can explain to you Bitcoin. I mean, like, what is it? What is this? What is this protocol? What is it freaking doing? Why? Why is this so hard? Because it probably is fucking wrong. They're probably doing something hokey. Like, that's probably what's going on here. Now, I could be wrong, but like, if you can't explain things simply, maybe it's simply not explainable. Maybe it's simply wrong. All right. I'm skipping this, dude. Like, I think I made my point, at least. Like, I still, like, where do I even start? All right, so let's start here. The Ouroboros Protocol, overview of design and analysis. We first provide a general overview of our approach. Literally, that's your title, bro. Just jump right into it. This is like fluff. Protocol analysis depend on a number of parameters. Okay, cool. K is the number of blocks a certain message should have on top of it. Okay, wait. The RB tree is part of the immutable history of the ledger. Okay, fine. This is literally K is the number of blocks for let's just say, a good probability of confirmation. So it's K's number of confirmations that you would need to have a secure probability in what's going on here. Okay. So, okay. Parameters that bound. Average. So, these. Is that epsilon? That's not like. Is that epsilon in this paper? Like, that looks weird to me. What am I? Why is my brain not pulling that up? What in the fuck? Like, is that epsilon what I was just looking at? Like, is this what the paper's fonts of epsilon looks like? I know this is sigma, so like, all right, whatever. Parameters that bound adversarial stake into stake shift in the sense that the adversary is 1/2 minus the error, initially bounded, as well as 1/2 minus some little error minus some other stake shift. Wait, error. Moreover, stake shifts no more than sigma occur over short enough time periods. Stake shifts no more than sigma occur over short enough time periods. What? Throughout the execution and moreover stake... What does this mean? The parameters that are bound... That they are... These two are parameters that bound adversarial stake and stake shift in the sense that the adversary is 1/2 minus... Let's call it epsilon. I think that's epsilon. It looks weird to me. Like it, like, all right, just like show you. Like, where am I? Oh, here we are. Like this. Is my brain just doing this wrong? Yeah, like this is what I expect epsilon to look like. A little more curly. Oh, fuck's sake. So like this is what I expect epsilon to look like. You see, this little thing here is a little. It's just weird. It's just so strange. Like, it just looks weird to me. My brain doesn't want to agree that that's epsilon. So it's epsilon and sigma. All right, fine. Epsilon and sigma are parameters that bound adversarial stake and stake shift in the sense that the adversary is 1/2 minus epsilon, initially bounded, as well as 1/2 minus epsilon minus sigma, bounded throughout the execution, and moreover stake shifts no more than sigma occur over short enough time periods. All right, did they define stake shift already? Okay. This is the first discussion of stake shift, all right? So that's the last one. There's only 9 mentions of that, and they're putting it in the very beginning. Okay. All right, so this... Okay, there we go. Our protocol assumes that parties can freely create accounts or receive make payments, and that stake shifts over time. So stake shifts over time. Stake shift is bounded over short periods. Specifically, for any chain adopted by an honest party, the observed shift and stake distribution between nearby prefixes of the chain are bounded from above. What the fuck are they talking about? Sorry. What the are they talking about? Like, oh my god. I want to fucking jump. I'm gonna jump. I'm so tired. Yeah, like, oh my god. I know. I just struggled over the character epsilon. I know that's so dumb. Like, my brain didn't want to read that right. So maybe I'm just, like, can't do it while I'm on stream or something. Maybe all of this makes perfect sense. But, like, stake shift is bounded over short periods. I feel like I gotta be the crazy one here. Like, why does this not read well? Specifically for any chain adopted by an honest party, observed shift in stake distribution between nearby... So I have to understand the concept of an honest party, the observed shift in stake distribution between nearby prefixes of the chain. Like, do you see what I'm talking about? This is fucking nonsense. Dude, guys, come on. Can I get some backup here? Am I the one, like, is this real? Am I the only one who's doubting whether or not there's an ounce of realness in this? Like, it's like, I can read this paper. I'm not a dumb guy. I don't think I'm that dumb. Like, okay, sure, I read this and maybe I 80% get it, 70% get it, even 50% get it, but I don't 0% get it, right? Like, this is, you can grok this. People have grokked this, right? This is so freaking dumb. It's so dumb. Why would... This is cult building one. This is bullshit 101. Create new languages around your stuff so that anybody who wants to become part of your in-crowd must adopt your terminology, your languages, right? If you want to become a good Thaden 13 level Thian Paladith, like, you gotta know what a Thaden is, right? Oh, Jesus. Alright. That's what I'm saying, Almarino. That's literally the thesis I open with. My problem with Ouroboros is that there is no easy explanation for it. Even if it did work, and it worked well, you would be able to concisely explain it. You would be able to, in 3 or 4 paragraphs, be able to literally lay out, oh, this is the properties that make this work. And anybody with a reasonable background, a reasonably sufficient background in the field of any of this stuff, I understood Ethereum. I understand all the stuff that I did not ever have a problem reading the Cosmos stuff. Those guys are on point, all right? I read like a little bit of Algorand. It's a little, I forgot it, but it's basically like signed. It's basically like sealed envelope voting, and then everybody reveals the envelope, basically. All right. Algorand made sense to me. Bitcoin, obviously, did not have a problem understanding the core concept behind that. Avalanche. I got Avalanche, guys. Like, I got it. I get it. I get the gist. I get the gist. That's all I need. Can I get the gist? I have not once in the entire history of Cardano's IOHK, any of that, been able to get the gist of anything that they're saying, other than a bunch of whiteboard stuff from 2018, which they have, I think, taken down possibly, because I can't find it anymore, where they were describing things which I know now to be literally impossible. So, dude, this is not geared towards academics. Wait, this is not geared towards academics, dude. Senri, no, this is not geared towards academics. I do not agree with that statement. This is geared towards, yes, this is geared towards academics. This is legitimately geared towards academics, okay? This is by experts in consensus protocols. All right? RVR is a distributed systems expert, okay? Goon is the third most cited person in Bitcoin, Ethereum, like anything Bitcoin-y, right? Anything he's the third most cited person in decentralized protocols, right? The first is probably Satoshi Nakamoto, but it could be Leslie Lamport. And the third is Goon, right? So, like, this is just freaking nonsense talk. This is 60 pages of nonsense talk. This is not geared towards academics, okay? There's a marked difference between this paper, which provides proof, evidence, graphs, tons of it, not just a little bit, but for the pseudocode to how to produce exactly what we're saying, right? Like literally, you could take this and go, oh, okay, I could write a program from that, and people have, right? Oh, can you tell me the gist of ETH2 consensus? I kind of get shards, but I haven't read much of the consensus itself. Here's the thing about ETH2 consensus. It changed a lot from when I first learned about it, but I feel like I might be caught up now. So essentially, there's a beacon chain, and this chain is entire purpose is to be the one that is the arbiter of check-ins, basically, of value on the system, okay? So just one chain, typical chain. This is validated with a classical consensus protocol in order to achieve higher throughput. It is not a proof of work chain. This beacon chain is a classical protocol, and it uses a source of randomness. Now, the present source of randomness that I saw was Randau, but that could easily be changed to BLS to actually BLS ring. Is it ring signature? No, ring signature is right word wise. BLS groups, whatever. To actually come up with a random number that is going to be used as a selection number, a source of randomness for the whole network to determine who's going to validate what shard in the next epoch. They divide up the chain by epochs, okay? These epochs are 6 minutes long. All right, so there's a 6-minute long epoch. And each epoch, a committee is selected for each shard. So say you have 128 shards, then some number of the validators that exist in the system will go to one of those 128 shards, jump on them, synchronize to them, or find a way to jump into the state, validate the transactions on that state for the epoch time, and then at the end of that epoch time, commit a state hash to the basically a proof to the beacon chain that says this is valid. Now, 2/3 of them have to commit that proof to positively attest to the beacon chain. If they fail to do so, and they do not get a positive attestation on the beacon chain of the correct number of the state being correct, the shard has no choice but to do a rollback. So the whole shard is rollback 6 minutes. There's no other way around that I can think of. You can't fix it. They can maybe ask for a revote, but that's it. Okay, so now you've got 6 minutes for an election, 6 minutes for the shard to do all the transactions. So you're sending transactions to a particular shard on the network. Then that transaction gets committed to the main chain, and then it takes 6 minutes to basically confirm it, because you need another epoch before you can actually do revotes and stuff like that. In the event it still fails, you've got to let the next committee that comes in validate the previous transactions. I mean, somehow they have to get up to date on those transactions. Otherwise, your transaction didn't even go through. That's my understanding of it. So essentially, let me say this again. You got a chain running a classical consensus protocol, so it could only have 100 participants before you start seeing degradation. You can add more, but you're going to start seeing protocol speed degradation. So they probably got more like 200, somewhere in that range, 250. And then that keeps it around 1,000 TPS. I think you can stay around 1,000 TPS there on the beacon chain. And then you have the shards, which are not technically related, but they have to check in with this. And they have every 6 minutes to do a bunch of as many transactions. Mind you, the committee has to jump onto this shard while transactions are going to this shard. Okay? So while transactions are going to this shard, a whole view change must occur, and everybody on the committee must be ready to get those transactions on that shard. So they not only have to be there okay, can I get to the state on that shard? Can I actually understand the state is correct? In a way that I could validate transactions in a meaningful way? And then on this shard, as a validator, can I validate the transactions fast enough so I'm actually ready to go on the next one? So the only way I can think to do that is to be in line, already listening to this transaction. You have 6 minutes then to actually be a validator, and so now you're lined up. I don't know if they're doing it that way though, but that's the only way I can think to do it, is that every time an election occurs, you have 6 minutes to jump on, sync up, and get ready to be a validator for 1 6-minute block the next time. Now, actually, I might be wrong about even that. In other words, you can actually do multiple epochs. So you can have major epochs and minor epochs. Minor epochs will just be the check-in time, and then you have major epochs, which should be like a 2-hour period where you're assigned, or even a 2-week period where you're assigned to that shard. But I don't remember if that's the case or not. That would also make sense. I just don't remember. I don't know if they did that. I'm sorry. So apologies to that if I got that wrong. There could be major epochs and minor epochs, and a minor epoch would be 6 minutes. And that's every check-in time period, which would then only handle the rollback situation, yada, yada, yada. All this so that people could just have a second chain, another chain, right? Another little chain that's also running a classical consensus protocol. Now, they're talking about limiting that to 128 validators. And the reason they chose 128 validator, I shit you not, the reason they chose 128 validators on ETH 2.0 when asked, is because, I don't know, powers of 2 seem like round numbers. That was their reasoning. No metrics, no questioning, no why would we pick that number, no what is the optimal number of participants of this shard. Literally just like, we like powers of 2 at Ethereum. Okay, cool. Well, you know what's also a power of 2? Your addressing state in the EVM, which is 256 bits, which is absolutely a crap design. Every single register, every single memory, all memory in Avalanche, I'm sorry, if the EVM is 256 bits, you may not have an 8-bit byte. It's not 32 bytes. It's 256 bytes, I'm sorry, of memory. Like, it's literally as big as it takes to store a hash. Like, that's what they're doing there. Wait, brain. Yeah, that's correct, right? Oh my God, it's been so fucking long. Oh man. I think it's the size to store a single hash. It is. Yeah, no, okay. It's 256 bits. Okay, I was right the first time I said it. Cool. That's better. Anyway. No, that still makes sense too. Okay, cool. Whatever. So anyway, the size of a... Why is my brain like doubting myself so much versus something as simple as bits versus bytes? Like, I can't remember. I'm screwy right now. Because I could store... Oh my God. Guys, somebody remember. Is it bits or bytes? I know it's ludicrous either way. But I think it's bits. The way I said it right was right the first time. But for some reason now my brain is like, are they actually worse than I thought? And then they did bytes and now I can't remember. Yeah, I think it's bits. Goddamn. Yeah, okay. It's bits. All right. So, yeah, it's 256 bits. I don't know why I went through that. My brain just like super doubting all of a sudden. So 256 bits is the size of a single... Anyway. Where was I going with all this? Ethereum is easy to understand compared to this. So, compared to all of this. My computer is now telling me I'm out of disk space all of a sudden. I'm not even saving anything to disk. Why? All right. So anyway, this is all right. Let me look at the old simple ledger postage protocol. Okay. what is this? Goon is live somewhere.
For you and from having the
Goon's always live somewhere. This is my time, guys. Stop that. All right. So this specification describes a protocol of the sender of an SLP token. So Don Wonton sent me the simple ledger postage protocol, which is a specification describing a protocol for the sender of SLP tokens to effectuate a transaction without the need for additional native Bitcoin Cash inputs to cover the output balance and or miner fees. Use of this protocol enables wallets to exclusively support SLP tokens without also simultaneously having to act as a wallet for native BCH. What am I looking at here? So wait. Broadcast the network. In exchange for providing this service, the post office can require payment in the form of an SLP token. As an additional output, this interaction effectively allows the sender to pay his network fees in SLP tokens as opposed to BCH. This is nonsense. This is dumb. Why would you do this? Why would you do this? Just pay in BCH. BCH is an SLP token. It already is an SLP token. Let me exchange my BCH for SLP tokens so that I can exchange for other token with using SLP instead of BCH. Why not just use BCH? Is SLP a stablecoin? Well, that I could see. I could see that. That's actually reasonable. I might have to roll back on that. If you did something where where all your postage was in stablecoin, then that's fine. However, I want to point out something. By doing that, you've created a canonical stablecoin, and what it's stable to. So if your wow, I am getting all sorts of like disk space errors right here. What is eating up my disk? If you have a bunch of sorry guys, brain's stopped because I'm getting alerts about disk space. If you have a stablecoin that's canonical in the system, it's just based off exactly a single coin, let's say a USD stablecoin, then you've established USD as the base currency of your system, which by the way is kind of stupid if you're trying to get away from fiat, because it's literally saying, hey, use fiat to pay. But you know, or you could use, I don't know, I guess maybe it's, I don't think this will work. Am I running BFC in the background? No, I don't run anything in the background. I'm at a disk space, like literally disk space all of a sudden. Doop. So anyway, can you give your view on dApp specific chains? Most of which are based on Cosmos SDK. I think they're fine. Anything that does dApp specific stuff is I mean, that makes sense. I don't have a problem with that. Like why would I don't see any harm in that at all. Like if you want to, like Avalanche is gearing towards that audience as well. Because basically you could take the Thor chain and stick it on an Avalanche subnet and it should work, right? So that's not a problem. All right. Deleted some of that, and then I gotta go to trash to make these alerts go away because they're literally So empty recycle bin, yes. Okie doke. That'll probably fix it. Okay, Thorchain might be difficult on... Why would Thorchain be difficult on Avalanche? What's wrong with Thorchain? For each coin, you need to run a specific node. That's still possible. They'll figure it out. I don't know. Like, so that's the thing, they'll figure it out. It's not that big a deal. Thorchain... So, no text editors like Thorchain might be difficult on Avalanche. I don't know. I don't think it'll make a difference. It's just Avalanche is just a consensus protocol, so... Yeah, I mean, if you want to make something that adapts that, then you can. Their security relies on the fact that they're completely sovereign. It would be great if they could use Avalanche consensus, but they don't need to be within the Avalanche platform. What does that mean? Their security relies on the fact that they're completely sovereign. What does that mean? All Avalanche subnets are completely sovereign. Like, they are, except you're just borrowing... I guess you're just like... People are choosing to validate for you through the Avalanche platform. There's nothing in Avalanche that's non-sovereign. It's not like it's dictating over your subnet. Subnets are an addressing system. So you could create a layer 1 network using the subnet. You do need to stake AVOX. You need to stake AVOX on the platform chain, but I don't see any reason why you need to stake AVOX to join a subnet. You can stake Thor tokens or VeChain or whatever their token is. If a validator doesn't have stake in your chain directly, the assumptions of proof of stake go missing. No, that's not it. So look, basically AVOX is a membership program. And right now the price is high to become a member. I don't agree with that, and nobody else does either, including internally at Avalabs. It's just something that's the case right now. AVOX is 2,000. It costs 2,000 AVOX to become a member of the AVOX Avalanche network. Okay, once you become a member, you can validate for other chains, and the idea as it's been presented is that you can stake with your native token. So they don't need... You need AVOX to become a member of Avalanche, and that helps you join other networks. Okay, so you have to join the Thor chain. You need to have Thor tokens. But to become yeah, I mean, that's it. Like, basically, to become a validator in general, you need AVOX which is gotta be cheapened. That price has gotta be lowered. To become a Thorchain validator, you just need to have Thorchain tokens. You don't need to have... Like, AVOX is a completely separate subject. Like, you know what I mean? Does that make sense? Like, the security of the network does not depend on how much AVOX you have. Your stake amount is not dependent. Like, your stake in a AVOX network does not correlate with your stake in the Thor network. They're two different staking protocols. Staking functions. Does that make sense? Amarino 99. Like, you don't need... Like, yeah, the core chain might be put on Avalanche, but I guess you'd still run the other nodes. I don't know what that means, dude. Like, I don't know what that means. I don't know what all these junk protocols do. And yeah, like, they're junk. Like they're like, whatever. There's no reason why Thorchain validators want to stake AVOX as well. Well, too bad. Like, you have to. So here's the thing: in order to become a validator on any of these networks, you have like you can just throw up your own like Avalanche or whatever. But that's like missing the whole point. Like, I don't think Cosmos is doing things correctly in that you should be staked in the Cosmos network to join. So here's the reason why Cosmos is the way it is because they can only have but so many Cosmos validators. They're bound by the classical limitations, right? So they do other things to like get around that. Like not everybody should be validating every single like Cosmos thing because Cosmos not hub but spoke, because not everybody can validate every Cosmos spoke, right? They're limited. They're all limited. Every single one of the other networks on the Cosmos ecosystem are all limited. They can't go beyond the bounds of classical protocols. When you are in Avalanche, every one of those validators can join any other subnet ad hoc, just based off the fact that it's like a discovery mechanism. You know what I mean? I don't care if you don't want people to stake an Avalanche primary network. Like, that's the point. You need to stake in the Avalanche primary network. You need to be a member of the Avalanche primary network to be a member of other chains. You know, especially since the Avalanche primary network will probably want security guarantees where you actually have to use the primary network in order to validate a successful transfer of a token with the optimal security. Does that make sense? Like, yeah, it's like it's not even about the token, dude. It's literally good for the network. So, all right, Avalanche is a pool of validators. It is a group of people that you can pull from. So as far as whatever, I don't want to talk like. So Avalanche validators are a group of people that you can pull from that can validate your subnet at will. Okay, this is a pool of validators. The largest pool of validators in the world. It's the universe of all validators that you can use to validate your subnet, right? And in everybody being a member of this large pool of validators, if your subnet wants to have the optimal safety or security when transferring your token to another subnet, for instance, or communicating with another subnet, for instance, it would want to go through the primary network, because then all your validators are validating this transfer, which are also part of the greater Avalanche validators, which are validating this transfer, which is also part of the other subnet validators, which are validating this transfer. So like, it's literally keeping everything super safe by doing that. It's not bad. So I think you know, the idea that you want like, oh yeah, I just want to run my own token on my own network, it's like, you're kind of missing the whole point. You're really missing the point. Like, the whole platform is built so you can build a network quickly. Good luck getting a ton of validators for your network unless you have this bootstrap mechanism provided by Avalanche. Like, that's the whole point. It makes it easy for you to build your own network. Your network can run its own token, but we need people to actually validate on the main Avalanche network to have this whole connection system around. It's totally necessary. Like, whatever. All right, so the point is, extent you're trying to rely on the primary network for security, even if it's just for transfers. That's the point. To an extent, you're relying on. Do you think it's? Do you think it's possible? Don Wonton said, "Do you think it's possible to see a subnet overtake the primary network?" Yeah, I do. I don't know what they're going to do about that, but I do. I think it's totally possible. Like, for instance, yeah, totally possible. Yep. So the whole point is to become a de facto standard, right? That's the point. Other people could just deploy stuff, but, you know, we're so far ahead of the game. We offer so many features and so many things that nobody else could get anywhere very easily. It's going to be very difficult to sort of, like, overtake. Plus, the fact that the whole network is enterprise friendly in the fact that there's a patent to protect it. I'm really happy with the patent thing. So far, the patent is pending only. Does that mean you can just use it without asking? No, no text editor. It means that with the patent there, you can protect your IP at any time. I believe you could still put in, like, yo, we've got a patent pending on this. We want you to hold off on your work until this patent clears, or at least send a notice that the patent is pending, yada, yada, yada. So, I mean, you can do stuff. You can make advancements in that direction, but, you know, you can't, if that patent clears, you're kind of out of luck. You just spend a whole bunch of resources for nothing. Because they could come back retroactively and just be, yeah, I mean, our patent application was on this date in May 2018, so we are ready to go. Like, we have claim to this IP and this patent, like, prior to that, or up to that, at that date, I should say. So all your work after that date, after we released our intellectual property to the world, after we discovered this, published it, and started building on it, and you guys read what we did, and we're like, oh yeah, that's a good idea, I'll do that too. We're gonna go, no, you can't, because we put in a patent application. Simply put, it'd be great if those DApp-specific chains could just use Avalanche consensus without relying on the primary network in any form. Well, I don't care. I think that's a terrible idea. I think that's a very stupid idea. I think that's genuinely the worst way to do things. You want people to have this shared network. You want people to have this addressed system for people to go through. I mean, this is a decentralized network, dude. Like, you know, you're supposed to be able to have as many people participating in this network as possible, and they're all agreeing on one thing. Who's able to do what, and where are they able to, and where is everything, right? So, like, the subnet and transfer tokens, yada, yada, yada. The subnet registry, which is in the P chain, is a great way to discover and have other people join your network. You are missing out on a huge pool of opportunity by not having that network there. I think it's dumb. If you want to just create your own little thing on the side, go for it. But that's what everybody's doing right now. There's a million shit coins out there, and all of them have no relation or any ability whatsoever to connect with each other. Okay, y'all moan about network effects, and y'all moan about, like, cross-chain transfers. Y'all moan about shared security, blah, blah, blah. This is the best you're gonna get. It really is. You need the primary network to... You are relying on... What do you mean, you are relying on the security of the primary network. A subnet could get bigger than a primary network, as you said. Yes, they could. Yep, they totally could. A subnet is capped in the number of validators by the primary network, but the value that is in the subnet can exceed that of the primary network. So the value that's captured in the subnet can exceed that of the primary network. Correct. Yes. You cannot have more validators in the subnet than in the primary network, though. You could have a side network, sort of. Yeah, market cap could totally outstretch the subnet. The subnet could totally be higher market cap than Avalanche token. Absolutely correct. Yes, because transaction fees in Avalanche, by the way, only count for the primary network and operations on the primary network, right? So subnets will be your own thing, right? Yeah, Don Wonton, I also think that could happen as well. Yep. So Don Wonton said a subnet can have subnets. Imagine if everyone made subnets on the subnet and ignored the default network. Yeah, all you need is one subnet doing that. And you are, you're absolutely correct. So that subnet's not going to get off the ground, though, without... So here's the other thing, is that these subnets would need to have in their client something which ignored the Avalanche primary network. Yeah. So at some point, they decide to pull the trigger and bypass the system. And the thing is, that can happen for any subnet. That can happen for any subnet, and suddenly there's this huge, like, everybody's just got their own subnet of subnet stuff, right? So that is totally possible, and that can happen. The question is, what does that gain? What do you gain from that? You see what I mean? Like, you gain nothing from doing that. That's the point. The entire point of Avalanche is so that there's a huge pool of validators to pull from. By saying, yeah, we're just going to not require, like, we're going to let you to validate without requiring you to be part of the Avalanche network, then you've kind of, like, just created your own network, which is like, why have this giant pool of validators to begin with? Avalanche is supposed to be as inobtrusive and thin as possible. Like, it's supposed to be, like, literally the thinnest stuff there. Like, nobody is supposed to actually have a whole lot of opinions about what you're doing. That's the design goal here. Because if we did have opinions, yeah, you'd probably just go and do your own thing that didn't have opinions, right? So this is what people have wanted for so long, and now that they're starting to realize that the consequence of that is that you have to sort of have a pool of people to pull from. Does that make sense? Like, all we are is basically a pool of people to pull from. Like, that's all that Avalanche really is in the end of the day. It's a bunch of primitives on an exchange chain. And you got the C chain, which is junk, and basically I don't even think much of it. It's just there to be... Can't you use a patent to force them legally staying? No, you can't. Here's the thing. You cannot have enterprise level content on those chains. So it'd be very difficult for an enterprise to integrate Avalanche into their enterprise solutions if they didn't have the backing of the patent. Does that make sense? So you have this subnet, and the subnet is, say, the Thorchain subnet, and they decide to just go off and use their own version of the Avalanche protocol to build their own network. Well, guess what? Thorchain's customers are now in violation of, they're using illegal software. We would send a CND to Thorchain saying, hey, look, your customers, because they are a private company basically, your customers are now using some software which is pirating or, in violation of our IP. And then the enterprise group can't use it. So the protection of the patent basically says that if you want to do enterprise level integrations, if you want to integrate with banks, if you want to integrate with Fortune 100 supply chain management companies, if you want to integrate with anybody in the financial institution, payments, you got to go through the network that is allowed, which is the Avalanche network. You have to pay the Avax, indexing fee. Basically, it's to create a sort of de facto standard around how people will discover and create subnets and chains under them. Literally though, if you look at what we've done, it's super not opinionated. Like, it really isn't. Other than that opinion, nothing else is opinionated. Yes, I'm advocating for the fact that you can literally, every validator is at your disposal. Every single validator is at your disposal if you use Avalanche on the primary network. Every single validator in the world. All of them are at your disposal. There's not, aside from that, that's really what you get to create your own chains. You've got this huge network of really secure transactions for cross transacting. It's really great in that respect, but like literally the entire purpose of the Avalanche primary network is to be that sort of like phone book, I guess you could say. Not even phone book, I don't know, just resources, a pool of validators to validate your network. As long as you can set the requirements to have stake in the chain's token, and that change, yeah, that's exactly it. It's fine. It doesn't hurt anything. The only thing people are complaining about is that they have to own a Vox. And it's like, you have to pay Ethereum transaction fees if you have, all right, so let's say I have Uniswap token that I want to do, and like I've got my Uniswap app, right? I have to pay my fees in Ethereum. I have to launch my contract using Ethereum. And then they're like, oh yeah, but the users of our token don't. Yes, they do, because they have to pay their fees in Ethereum. We don't even ask your users to pay fees in Avax. Your users do not have to pay fees in Avax. Your users of your system, they pay fees in your token on your subnet. Okay? Your token on your subnet is being paid is the fee mechanism. All right? You get to determine that. However, for somebody to become a validator on your network, they must pay let's just call it the HOA fee of Avax. And hopefully that'll be small enough that it won't hurt anybody's feelings. And we'll have as many validators to pull from as humanly possible. They have to pay that HOA fee of Avax, okay? And then they also have to stake in your network using your token. That would be the ideal system in my mind. Like that's basically what I've talked to everybody else about, and they seem interested in that. But we'll see what ultimately, and that's kind of what's insinuated in the roadmap. That's what they're insinuating they're going to build. So, like, look, that's reasonable in my mind. Like, you're just basically paying an HOA fee. You're basically saying, hey, look, I want. And by the way, for anybody who's foreign, like, it means homeowners association fee. It's basically a fee you pay to keep the neighborhood looking nice. Yeah. So it's like literally just a fee you pay. The neighborhood makes you pay. If you buy a house in a particular neighborhood that wants to be kept up and nice, then that neighborhood requires you, by virtue of buying that house, to pay what's known as a homeowners association fee, which is just a fee to keep like the common areas clean and to make sure that everybody's house is in compliance with the guidelines. So like, for instance, your shutters may not be purple, that kind of thing, because the idea is that by joining this HOA, then they ensure that the property value of that neighborhood will always go up relative to the area. That's the idea of it. It's not actually my favorite way of doing things, by the way. I definitely like the idea of not being in an HOA more, but this is not a house situation. This is more like a common resource situation. So I don't think the HOA fee thing actually applies here. I don't think it's a good example. But long story short is that basically it's a pool of, mother of God, I forgot to turn that off. Okay, cool. So yeah, it's just a pool of it's literally a pool of resources, and for you to use that pool of resources is a common resource, like basically. So everybody wants to participate in this common resource section. Here's the other thing: look at it from the validator's perspective. Okay, don't just look at it from the subnet creators, but look at a validator's perspective. I want to validate on your network. How hard are you going to make it for me? If I have to send a transaction to your specific chain using your specific transaction format in the specific way that you outlined it, okay? That's a huge barrier to entry to me. And if it's a huge barrier to entry to me, it's also a huge barrier to entry to you. So the fact that you can join a subnet by installing a VM, which is just like, should ultimately be like this one-click operation, hopefully. And then you also say, I want to validate this subnet, which also is just like a one transaction operation. And you could do that for any hundreds of thousands of other subnets that are out there. You've reduced the user experience down to like 2 clicks, maybe even 1 click, because you could just say 1 click. I want to validate on this on this subnet using this token I just bought, and for this time period, and you hit submit, and then you're suddenly validating that transaction because your UI will automatically download it and install it on your system. And it's gonna all happen in 1 click, guys. Like, that's it. So chain sovereignty. What is chain sovereignty? I don't know. Are you asking me? What is chain sovereignty? So Avalanche primary network has 0 opinions about a subnet and the chains that reside on it. It doesn't care. The actual interface is pretty straightforward. It's like, does it implement, which consensus protocol does it implement, and how do you accept blocks? And that's just for subnets validators to know what to do when they join. Has nothing to do with, I see. So like, yeah, sovereignty of every single subnet is a layer 1. Avalanche is simply a layer 0. Like, we are literally, we are not sovereign over your subnet. Does that make sense? Like, your subnet is not something that the Avalanche network has any opinions about, other than what it takes to set it up, right? Once somebody wants to join your network, they decide to join, and they're validating on your network using your rules. Okay? This is your rules. Like, this is the thinnest you can get. It is a very thin protocol. I'm advocating for sanity here, guys. I'm not advocating for like literally, this is sanity. We need one root network that everybody can pull from. It's a common language for you to work with. It is a way for everybody to speak. This is the Tower of Babel, okay? Where everybody speaks the same language, right? This is the one place. Of course, that's a terrible analogy because that thing ultimately fell. But this is the one place where everybody speaks the same language, and so you could go find other people who have, you know, things that you're interested in and participate in their playground. That's what this is. So I don't know. I'm really. I get this from Corey, my buddy Corey. Like, oh, I don't want my users to have your, like, that's not how he sounds, but I don't want my users to have your, like, your token just so they could join my network. It's like, well, tough shit, right? Like, it's not about you. It's about the network effects. It's about the bigger picture here. You think you're going to get all these people to join your network. That's fine. That's cute. You could get a lot more if it was easy for everybody to join. And yeah, it's just like such a terrible argument. And the worst part is like, oh, they're just greedy. It's like, no, you're greedy. You're the one not wanting to play with other people. You're the one that's literally like straight up saying, I just want to steal your stuff that I had no hand in actually building, and then I want to use it so I can play. No, we built the most generous system possible. This is generous, like ridiculously generous. Like there is no primary force of anything. We're trying to make a system where everybody can be a validator on everybody else's subnet, and subnets can have valid subnets as well. Like this whole system is built in such a way that it makes it really easy for people to join once and participate anywhere. You know, that's it. It is like, and honestly, I think the only reason people are giving a crap right now is because Avok's price 10x'd so quickly. You know, like super quickly. Like if the price didn't go up so fast, like I don't think this would be a conversation we would be having. Like the price went up so quickly that 2,000 Avox, which is like $2,000 when we first launched, not even, went up to like freaking, you know, $80,000 so fast. And then it's like, oh yeah, I got priced out. I can't be an Avalanche validator anymore. It's $80,000. It's too much. I agree, it's too much. Everybody agrees it's too much. We should lower it. I don't know what's taking so long on that, but we should lower it. Like really, we should lower it. It should be really cheap. It should be really cheap to be an Avalanche validator. Like, it should not cost a whole lot. It should cost more than a server, maybe like 3 times more than your server. Like let's say you run a like 4 or 5, whatever. Like $500. $500 is like reasonable. You know, $250 might even be reasonable. But, you know, let's see. Its current price is. So the current price is $11.48. That's yeah, $22,000 at the current price. It jumped up to $80,000, mind you. It's doing way better now. But $22,000, $23,000 to run a node. That's too much. It's way too much. All right, so in a subnet, you should be able to find your own token. So I think subnets that have look, the validators from a subnet need to also, if you want subnets of subnets, then the validators of the subnet also need to be validators of that subnet. That's how that actually works. So that means that, well, subnets are technically live now, by the way. They're just not open and permissionless. I have lost ridiculous viewers during this stream. Like, we started out strong. I had like 20 viewers. And as I went over Ouroboros and all this other stuff, like, it just went downhill. Like, nobody cares about this tech stuff. Like, nobody cares. Nobody cares. This tech stuff is, like, such not good topic. Like, nobody fucking cares. I'm telling you right now, I watch my own viewers. Like, it was going up when I was talking about the fun stuff in the beginning. And as soon as I went to Ouroboros and talking about that, like, it went downhill. Nobody cares about this stuff. Literally, there's 8 people in my chat right now that care. That's it. What a frustrating day. I shouldn't get like actually frustrated on stream, but I kind of am. All right, guys, let's talk about something actually entertaining, because I'm about to log off. Plans on having a smartphone nodes. Yeah, there's some talk about that. A light client node would be okay. Just something to send transactions. Like, you don't want a validator. You don't want a validator node on your cell phone. You just don't. You don't want that. That's not interesting. You want just something that's a light client that can actually just send a transaction. And that's pretty straightforward. Technically, you can kind of just do it by sending it to any node and just it should go through. But if you want like a little node on your client that could just send a transaction and check state, yeah, that shouldn't be a big deal. Problem right now, though, is that the state is large. And that's all almost entirely because of the C chain. C chain state is freaking huge. That's because the EVM is the EVM in the way that it is. But they're doing work to actually reduce that state size on the EVM and the chain size, which, by the way, is unnecessary. So I think the state size is 8 gigs, and I think the whole total database size is like 40. So just by having a way to jump into the state, I think you're able to reduce that sync time, that bootstrap time quite a bit, and the use on resources. But yeah, I think just having a node which builds and broadcasts transactions on a cell phone, that makes sense. I don't think you need to have a validator. That makes no sense. I would not have a validator on a cell phone. That makes 0 sense. But yeah. All right. So I didn't talk about any of the cool stuff today. John McAfee died. Like I said on my last stream, when 8 gig DB size coming, I don't know. Yeah, I don't know. Y'all got me riled up every single time. I don't want Avox to validate my subnet. Okay. We'll use your own token. Well, I don't want all my validators to also have a Vox. Okay, why not? Happens every time. Patents. Why do you gotta have a patent? Well, they did invent it. Oh, I'm sorry, Team Rocket invented it. Like every time. It's really getting old. I struggle because it's the same question every time, and it's just like, all you need to realize is that there's a common utility here. Like, the whole network is built in such a way that anybody in the network can become a member of your subnet. Do you know how hard it is to build a layer 1 network from the ground up and have it be successful? Like, do you know how hard that is? That's a hard job. It's a hard task. Most people cannot successfully do it. But we're actually taking the concept of like dApps, which are pretty easy to get off the ground, relatively, and turning it into, layer 1 networks, we're trying to make those easier to get off the ground. We're actually trying to make it easier to have your own little network, like your own network that you run off of. Like, we're actually trying to make this easier. And people don't like that? I don't understand. Yeah, and it's not even like a ridiculous fee, it's a one-off. So Sinri477 said you're basically paying Avalab's maintenance fee. It's like, yeah, it's just a one-off. It's like, just to be a validator, you just need to do this. So, it's not that big a deal. I guess you need to talk to biz people about subnets. Yeah, I don't know. This is a public utility. Like, the whole platform is a public... It's called a platform. It's not called, like a... You know what I mean? Like... Not dismissing the huge advantages that a shared networking layer could have. Just have my doubts on some aspects that are not often considered. We still have to see how they'll be implemented, though. Okay. What aspects? Like, that's the thing, is like everybody's got like these concerns, but nobody is actually able to say real concerns. A lot of the times the concerns they're saying just aren't real, like just not happening. Like, oh, all my validators have to pay your fee. No, you don't. All your subnets can have their own fee structure, as far as I'm concerned. Okay, or like, I don't want them to, like, it really just, it's kind of strange. Like, I don't understand. In a subnet, you should be able to define your, oof, where do I jump up to that? I can't read, how do I jump to that? See thread, okay, there we go. In a subnet, you should be able to define your token economics. I think you can do that. So I inflate on my chain. Now, how is the primary network aware of that unless every validator syncs with me? So that I'm not sure of. I would think you would just need minting to happen as a token on the X chain, right? That's easy. You don't mean inflate. I guess you just mean like extra mints, right? Mint over the amount you're supposed to mint. And yeah, I think you would just need to make the minting function occur on the X chain, or the X chain validates your minting function somehow, right? It just needs to say that. That could be possible. I'm not really sure. That's not something that I can solve right now. Pretty sure that there's a solution though. All right, guys, it's getting late. I'm getting tired. Clearly, I've lost my cool, which is not cool. I should not lose my cool. But I keep having this conversation with a dear friend of mine, and he just refuses to hear the right solution. It's driving me crazy. We need one chain to rule them all. We need one chain, and not rule them all. We need one chain that's kind of like the root, the measuring stick for all value. And I think that Avalanche is that stick. I do. I think it's that stick. It's simple. It's so simple to be that mechanism that people go through to actually get to another piece of value, right? I think it's a simple language. We need one language of value. We need one way of having, like, everybody can support this coin pair, right? Avalanche, your token. Avalanche / your token coin pair. I feel like that's a reasonable thing to do, right? Nah, don't worry about being less annoying. Don't worry about that. That's nothing to do with you. This is really just because you touched on a point that's like driving me crazy from another perspective. You know, it's driving me crazy because there's such conflict in the rhetoric that people have and what they really say they want. They're like, we want multi-chain, we want cross-chain transfers, we want easy layer 1 networks, we want low fees, we want proof of stake, we want validators at any scale. Oh, but we don't want to pay a Vox. We don't want to own your tokens. Like, how else do you think this network is going to be secured? Like, how else do you think this will happen? Do you have a proposal for a different way? Because I don't hear it. I know. I know you weren't aware. I know. All right, guys. I'm gonna end it. I'll catch you later. Thank you for coming, as usual.